Hey guys, so let us start with organic chemistry. Okay, so in this video I'll like to cover all the important reactions for the exams. Okay, so in this video I'm not taking any mechanisms or any basic concept. This video is just meant for the quick revision for the important reaction that you should remember for your exams. Okay, so in organic chemistry, so let us start soon without wasting the time, right? Okay, so first of all, primary alcohol. We know what is an alcohol, right? I think everybody knows that because it is a basic thing. If you study the things properly, you know it, right? Okay, so it is simple. So alcohol, we know what is primary alcohol. So primary alcohol is nothing but OH group, right? So primary alcohol means OH group, and for example, I will explain it. For example, ROH, okay? One R group is nothing but it can be an alkyl group or aryl group. This is called as primary. If there are two R, okay, two alkyl or aryl group, we call it to be a secondary, and if it is three, we call it to be a tertiary. Simple, okay? So primary alcohol on oxidation will give me aldehyde. What is aldehyde? CHO group, right? Okay. And this aldehyde again on oxidation will give me acid COOH is a formula. Okay, now this is ulta 2. Okay, so primary alcohol on oxidation will give aldehyde, and this aldehyde on reduction will give primary alcohol. Similarly, aldehyde on oxidation will give me acid, but don't write acid on reduction will give aldehyde. It is wrong. Actually, acid on reduction will give primary alcohol, not this point. Second point, we told about the case of primary alcohol. Next comes secondary alcohol. So secondary alcohol on oxidation will give ketone, and ketone on reduction will give secondary alcohol. Simple. I haven't written tertiary here because tertiary is one of the least oxidizing or reducing substance. Okay. Now third important reaction is, this is called cyanide, right? Cyanide on hydrolysis gives, this is actually partial hydrolysis is taking place. Okay, so on partial hydrolysis, this cyanide will convert into amide. CONH2 is called as amide. Okay, you need to note. Okay, now because many are confused with amide, amine and all, so you need to thorough with that. Okay, what is amide? This is amide, CONH2, and this I told partial hydrolysis will give me amide, but on full complete hydrolysis this amide will give me acid, that is COOH. Clear up to this? And if I take this same cyanide and if I reduce it, I will get primary amine. Amine means NH2, amide means also NH2, but amide means CONH2, amine means just NH2. Okay, so CH2 also it is okay. Primary amine means it contains only one R group. Okay, now so we know that cyanide is CN, so isocyanide means NC. Okay, NC. If you didn't see isocyanide and if you are seeing carbalamine, both are same, don't get confused. Okay, so NC on reduction. Okay, whenever I say reduction I mean hydrogen, and whenever I say oxidation I mean oxygen. Okay, that everyone knows. So isocyanide or carbalamine on reduction will give me N-methyl secondary amine. Okay, so this is N-methyl secondary amine. Next, acid. Okay, acid on NH3. In presence of NH3 I will be getting ammonium salt. NH4 is ammonium. Okay, and CO is salt. Okay, so ammonium salt, and this if I remove the water, removing water is called as dehydration. Removing hydrogen is called as dehydrogenation. Okay, these are the part where students get confused, but it is simple as that, because dehydrogenation, so hydrogen, so removal of hydrogen. Dehydration, we already know what is hydration means. Like in summer season we will be getting too hydrated and all, we used to hear that word. Hydration means water related, so removal of water is dehydration. So this ammonium salt on dehydration will give me amide. This amide, both are same. Okay, now the next important reaction is, okay, the next important reaction is CONH2. What is CONH2? Amide. It on dehydration will give me, that is removal of water will give me cyanide. Don't get confused. Here ammonium salt on dehydration will give me amide. If I again dehydrate it, I will be getting cyanide. Okay, you have to connect and study. And then aliphatic primary amine in presence of NaNO2 and HCl will give me alcohol. NaNO2 and HCl, in that we know that's electrophile is nothing but the HNO3, right? So will give me alcohol. Then this was a case of aliphatic primary amine. Then in case of aromatic primary amine, there's NH2 in presence of NaNO2 and HCl, same thing, but aromatic primary amine will give me N2Cl. Remember this, children. So whenever if it is aliphatic primary amine, the product that I get in NaNO2 and HCl is alcohol. But if it is aromatic, it is diazotization reaction, that is, it will give me N2Cl. Okay. Now, if I take this N2Cl and add C2H5OH or any alcohol, we'll be left with the hydrocarbon, that is hydrogen. Okay. Now, and the same N2Cl, if I add water, I will be getting as alcohol itself, the same reaction. Okay. Here we took NH2 and NaNO2 and HCl to yield OH, that is alcohol. Here we took N2Cl and hydrolyzed it in order to get the alcohol. Okay, part. Then next part is N2Cl. N2Cl is diazonium chloride. This diazonium chloride in presence of copper halide and hydrogen halide. X is, we know, halogen, right? So it can be chlorine, bromine, fluorine, iodine. But fluorine is not much preferred because of its small size and anomalous properties. And all, it is not much preferred. So N2Cl on Cu halide, copper halide and hydrogen halide will give me the halogen part. This reaction is called as Sandmeier's reaction. Then comes the Getterman reaction. Getterman reaction and Sandmeyer reaction is a pakka same. The only thing that you have to do is remove the X. Just add Cu and HX. Okay. Remove the X part. You will be getting the same reactant, same product, but reagent part, just remove the X. You will be getting the Getterman part also. Okay. Clear? Okay, now let us take any primary amine. Okay, taking any primary amine and adding CiCl2 and alcoholic KOH. So there are many questions with alcoholic KOH and what another thing? Yeah, alcoholic KOH. So in alcoholic KOH, it will be always beta elimination reaction takes place. Okay. Here I am not explaining any mechanisms because in entrance exam we don't have time to write the entire mechanism in order to find out a small product. So we have to study only few things. That few things I am telling in point wise. Okay. So aryl amine, on adding CHCl2 and alcoholic KOH, HCl will be removed and we will be left with the isocyanide NC. This is otherwise called as carbylamine. This reaction is called as Hoffmann carbylamine reaction. And there is one more reaction for Hoffmann, that is Hoffmann bromide degradation reaction. This is also very important that I will discuss. Okay. Now the next part is this is some acid chloride. COCl means this Cl means chlorine and this COOH is acid, right? So acid chloride on in presence of hydrogen. Hydrogen means what? It is undergoing reduction, right? In presence of palladium and BaSO4 will give me aldehyde. This reaction is called as Rosenmund reduction. And acid in presence of soda lime, we will be left with the hydrogen. This reaction is called as decarboxylation. Whenever you see COO, this is removed as carbon dioxide and what is left? H is left. That's what I wrote here. And in many questions, like if you see H and Cl together, remove it, and if you see Na and Cl together, remove it. Likewise you have to do. Okay. And yeah, that's how you have to proceed in this questions. And this one is this on reaction with zinc and HCl. Okay, this reaction is very important, children. This is called as Clemmensen reduction. This will yield this is zinc and HCl. This is actually a metal acid. We can call it as metal acid. Nothing takes place, only this oxygen will be removed and hydrogen is added. That's the only thing here taking place. This reaction, if you use KOH and NH2 and H2, this is called as hydrazine. Okay, this is called as hydrazine. This reaction is Wolff-Kishner. Whenever you see this reactant and hydrazine as one of the reagent, then make sure that it is Wolff-Kishner reduction. And whenever you use zinc and HCl as the reagent for this reaction, it is Clemmensen reduction. But the products are still the same. Just remove the oxygen and add 2 hydrogen to it. Even though it is very big question, we don't have to bother about the rest of the part. We have to bother only about the oxygen part and remove the oxygen part and add 2 hydrogen. 2 hydrogen means H2. Okay, not 2H2, it is H2. Okay. Then amide. Amide in presence of Br2 and KOH will give me primary amine. Okay. This one is called as Hoffmann bromamide degradation reaction. Okay, because from the name itself, bromine is used to Hoffmann bromamide degradation reaction. So bromamide, so from the name itself actually you have to study the reaction. Hoffmann bromamide, so brom means bromine, amide means amide, degradation means it is actually reducing, so the CO will go out and the final product will be NH2, it is reduced, right? So this is a reaction. And next is, whenever you see OH reacting with PCl5 or PCl3 or SOCl2, we will be left with the pure chlorine. And we have studied in haloalkanes and haloarenes chapter that pure haloalkane can be obtained with the help of SOCl2. This is not that reaction, I just told it when my mind struck that when I said this point. Okay, so this you have to remember it. Then this is ester. Ester on hydrolysis will give me acid and alcohol. Okay, we can study one more reaction is actually there. Acid plus alcohol give ester. We have studied it. The ulta of that, that's the only thing difference. Okay, so if I add two acids, COH, and what happens, H2O will move out. Okay, H2O will move out. Suppose this OH will move out, one OH from here will go out, and H2, one hydrogen will also go out. So COO, this is anhydride. And if I want this acid back, what I have to do, we have to just add water again, we will be left with the same thing. Okay, then if this nitro, into this nitro group, if metal acid reduction takes place, metal acid means like we have studied like here this reaction, Clemmensen reduction, zinc and HCl, this is an example of metal acid reduction. Okay, so here also if I take zinc and HCl, this will lead to remove this oxygen, add hydrogen, the same trick we used here also, the same one. Okay, so we will be getting primary amine. Okay, the next point is, the next point is, any aldehyde or ketone in presence of Grignard reagent, RMGX is Grignard reagent, will give me CROH. How did I get this? I got this R will go to the carbon part, and O and H, this hydrogen, H2O is H plus and OH minus, right? So one H will go here because this is positive, this is negative, and in RMGX we know R plus and MGX minus, that reaction mechanism you already know, I suppose. Otherwise please study that and then come to this video. Okay, then if I have some alkyl halide and I am treating it with KCN, what we have to do is just remove this K and X, the remaining is CN, that's the answer. Then COH, acid, plus any alcohol or phenol on dehydration. Dehydration means, I told, it is removal of water. So OH from here and one H is removed. So we will be left with COO and one reagent C will come, and we will be getting product as ester. Okay. Now same thing, alkyl halide, taking any alkyl halide and treating with AgCN, we will be removing Ag and X. The leftover is CN, right? Not CN, NC. This is isocyanide. Remember this point, this is very important because everyone have the temptation to write, because Ag and X is removed, the remaining is CN. Everyone have the temptation to write CN, but it is NC, isocyanide. If you write CN, it is wrong. Okay. Now this is actually called as ozonolysis. So this part, okay, so this one on treating with ozone is O3 plus H2O plus zinc. Okay, zinc, whenever you see, it is reduction, and you have to remember some oxidizing agents like KMnO4, K2CO7, PCC, these are all oxidizing agent. Hydrogen, palladium, BaSO4, zinc, these are all reducing agents. Okay, so this one in presence of ozone will give me one oxygen will go to like this. Okay, O3 is there, so consider it as O2, and one oxygen will go with this part. Okay, that's why I got this one, and another oxygen will go to this part. Okay, that's why I have got this one. Okay, so this is actually ozonolysis reduction, and this phenol on reaction with CHCl3, I use both as NaH, but when I use CHCl3 I will be getting salicylaldehyde, but if I use CCl4 I will be getting salicylic acid. Okay, that's the difference. You have to remember, phenol in presence of CHCl3 we will be getting aldehyde, CCl4 acid. Okay, now RX plus RONA, this is nothing but haloalkane plus any sodium salt of that alkane, I mean halogen, not halogen, sodium salt of that compound will give me ROR. What is happening over here? This Na, I have told that if you see Na and Cl, remove it, NaCl as NaCl. Here also Na is there, X is there. X is nothing but fluorine, chlorine, bromine, iodine. So if consider to X as Cl, Na and Cl will move out, then ROR, that's a product. This is Williamson synthesis, this is a ester. Okay, the next thing is RCHO in presence of aluminium. This name I actually forgot it. I will surely put in the description if I remember it. Okay, so RCHO on this presence will give me RCOOCH2R. What is happening over here is nothing but we have to add to this C, we have to add 2 oxygen, I mean like we have to add 2 oxygen in between the C, so it will be RCOOHO, but we have to add again CH2 from this. Okay, so it will be like this. Okay, now this one, if you look this one, you any carbonyl compound in presence of H2NZ and remove the water. Okay, then you this H2 and O is removed, then the leftover just combine it together, or using a glue fix them together. Okay, now this aldehyde in presence of concentrated alkali will give me acid plus alcohol. This reaction is called as Cannazaro reaction, and you have actually one more reaction that is called as aldol condensation and cross aldol condensation. So what is in aldol and cross aldol condensation is, in case of aldol condensation you can do it only if you have an alpha hydrogen atom, and for cross aldol also you need alpha hydrogen atom. But there exist some people like who does not have this alpha hydrogen atom. So aldol and cross aldol do that reaction only if it is having alpha hydrogen, but other will undergo, those who does not have any alpha hydrogen will undergo Cannazaro reaction. So what is this alpha hydrogen and cross what is alpha hydrogen actually? For example, if I take CHO, okay, carbon, this carbon, if it is attached to any other carbon and that carbon in turn have hydrogen, then it is said to be alpha. But for example, if I take CHO, this part, there is no neighbor to him, right? No one is his neighbor because his habit is like that, behavior is very rude, so no neighbors is there, so no hydrogen is there to them. Okay, so it is not an alpha hydrogen, so that time this will undergo Cannazaro reaction and not aldol condensation reaction. For example, if I take another like CH3CHO, this reaction, if you see that this is the part, okay, this is the functional group. To this functional group one carbon is attached, this carbon is called alpha carbon, and to this alpha carbon hydrogen is attached, it is called as alpha hydrogen. So it can undergo aldol condensation as well as cross aldol condensation. Clear? Okay, so here we studied Cannazaro reaction. Where is it? Yeah, this is a Cannazaro reaction. Here there is no alpha hydrogen atom, so it will be converted into acid and alcohol. Okay, now this alcohol, if you treat with HCl and anhydrous zinc chloride, it will give me Cl. Okay, now this reaction RCOOAg, that is the silver salt of any alkyl in reaction with bromine and CCl4 as a reagent will give me R and Br together, RBr, and COO means CO2, it will go away, and we used one Br to R and another Br is left. Br2 means BrBr, right? BrBr. Okay, one Br, okay, BrBr, one Br goes with R part and another Br goes with AgBr, and the leftover COO is CO2. Similarly, RMgX, again Grignard reagent in presence of HZ. HZ means it can be hydrogen containing any compounds, H2O, ROH, I have given the examples, will give me Mg and MgX and this Z will combine and R and H will combine. Okay, now this is calcium salt of any acid. This one, if I heat, what happens? CO and CO3 will be removed and the remaining is R, CO and one more R is there. This is the remaining part. And now this is called as calcium formate. What is calcium formate? And this calcium formate and calcium salt of any acid combines together, and if you heat it, we will be left with aldehyde and CaCO3, that is calcium carbonate. Okay, so this is the organic reactions, and organic is a subject which is like a whole ocean or sea which cannot be covered in one video, as you already know. But I have seen many videos like organic chemistry one shot. Those are like 1 hour, 2 hour, takes so much of hours. But as I'm using a phone, I cannot record it as there is only a limited time. So I have covered most of the important reactions, but still there are few reactions. If you want, so I will put the video one by one. Not one by one, actually the half of them is covered and only a few of the reactions is left with. So these are the important reactions. If you study this reaction and go to any competitive exams, you will be definitely benefited by watching only this one video itself. So if you like this video, please like and subscribe and share to your friends. Okay, thank you.